All right, in this section, we're going to be looking at the Kruskal-Wallis Test. Let me define what that means before we actually do any examples. So, the Kruskal-Wallis Test is a non-parametric test that can be used to determine whether three or more independent samples were selected from populations having the same distribution. The setup takes the following format: RH sub 0 and RH sub A. H sub 0 would be something like all of the populations have the same distribution. Or at least one of the populations has a distribution that is different from the others. Our test statistic will look like the following. We're going to be using the chi-squared table, but the test statistic nonetheless is the letter used is H. We have 12 divided by capital N times capital N plus 1 times R1 squared over N1 plus R2 squared over N2 plus plus R sub k squared over N sub k minus 3 times capital N plus 1. What are all these things? Well, capital N, it's the sum of the N sub I. N sub I is the size of sample I. K equals the number of samples. And then R sub I equals the sum of ranks for sample I. Performing a Kruskal-Wallis test. All right, all we need to do first, verify that the samples are random, independent, and each sample size is at least 5. So for each n sub I, just make sure that each one of those is greater than or equal to 5. 2. State H naught HA. 3. Specify alpha. 4. Since we're going to be using the chi-squared table, we'll need some degrees of freedom. So the degrees of freedom will be k minus 1. That's the number of samples, minus 1. 5. Use the chi-squared table to determine critical values. Find the ranks for each sample. 7. Let me put it to remind you, the test stat. We're going to use H equals 12 divided by capital N times capital N plus 1. R1 squared divided by N1 plus R2 squared divided by N2 plus however many of these you happen to need up until you get to R sub k. Remember, k is the number of samples. And then don't forget this little piece at the end. And then 8, make the decision. Note, this test is always right-tailed. All right, here's our first example. We have a researcher wants to determine whether there's a difference in the hourly pay rates for nurses in Indiana, Kentucky, or Ohio. So they're comparing the pay rates of each of those states. What we want to do first of all is let me label a few things here. We have 1, 2, 3 samples. In each sample, I have 1, 2, 3, 4, 5, 6, 7. I have 7 in the first sample, so n sub 1 equals 7. N sub 2 also equals 7. And n sub 3 equals 6. Capital N equals 7 plus 7 plus 6. That's going to equal 20. And finally, K equals 3. So first, let me get my H sub 0 and my H sub A out of the way. So my H sub 0 says that the pay rates are the same for all 3 states. And then the H sub A is at least one state pays at a different rate than the other states. So the first thing we want to do is organize the entire list from top to bottom, and then inside of that I want to make sure that I organize each one of the samples. So let's start. What you want to do is find the absolute smallest number anywhere on the table and then start going from lowest to highest. So I'm going to just start going through. The lowest for me is 2542. So that will be number 1, 2542, and that came from Kentucky. Let me do that since I'm using K for something else. So let me slice this off and let me look for the next item on the list. The next lowest item on the list, it looks like it might be 2613. And that came from Indiana. Then after that, it looks like 2640. And that came from Kentucky. And then number 4, 2734. That came from Ohio. 2768. That came from Indiana. So I've marked everything off. Now what you want to do is Indiana was 1, Kentucky was 2, and Ohio was 3. So let's see, let me have that back. Indiana was 1. So 1 was Indiana. So R sub 1 will equal the ranks for all the Indianas. So let me go through the entire list of Indianas and list the ranks. So I can see that I have a 2. Then I have a 5. Then I have an 8. Then I have a 9. An 11. 14. 16. I think that's all of them. How many do I have? 1, 2, 3, 4, 5, 6, 7. That's right. So let me add them all up then. 15, 24, 35, 49, 65. Number 2 was Kentucky. So its sum of ranks. Let's look for all my Kents. I have 1 plus 3 plus 6 plus 10, 12, 15, 18. Let me make sure I got all these. 1, 2, 3, 4, 5, 6, 7. Good, there were 7 of those. For this, I'm going to get 4, 10, 20, 32, 47, 65 also. And finally, so I can keep it all on the same page, let me throw Ohio in here. So R sub 3, let me get all the Ohio ranks. 4 plus 7 plus 13 plus 17, 19, and 20. That'll be 11, 24, 41, 60, 80. Now I'm prepared for my test stat. H equals 12 divided by capital N times N plus 1. I only have 3 samples, so I'm going to have R1 squared over N1 plus R2 squared over N2 plus R3 squared over N3 minus 3 times capital N plus 1. 12. Now my capital N was 20. N plus 1 will be 21. R1 was 65, so I'm going to do 65 squared divided by N1 was 7. And then I had 65 squared divided by 7 again. but then for R3 that was 80. So 80 squared divided by 6 minus 3 times 21. And let's let the calculator do the whole thing. Now the way I'm going to do it, let me pull it to the side so we can see the whole thing. You can do it in pieces, but the way I'm going to do it is I am going to first do my 12. I'm going to divide. Now in parentheses, I'm going to put 20 times 21. I'm going to end that parenthesis. Now I'm going to start this big parenthesis over here. So I get my 65, square it, divide by 7, plus 65, square it, divide by 7, plus 80, square it, divide by 6, finish that parenthesis, and then do minus 3 times 21. And I get roughly 1.966. Now let's go ahead and get the critical value. Here I'm going to need my alpha. Remember, these are always right-tailed tests. My alpha is 0.05. K equals 3, so the degrees of freedom is K minus 1. That'll be 3 minus 1. That will equal 2. And as I mentioned, use the chi-squared table. So that'll give me a chi-naught squared will equal. Let me go ahead and pull that table up. All right, let me increase the size here. The degrees of freedom is 2, and the alpha is 0.05. So it looks like 5.991 is our critical number. So when we look at a picture of this, we're going to get something like this. And when we look at this guy here, it's safely in the non-critical region, so do not reject H naught. All right, here's one last example. This is a pretty short section here. Let me label my things 2, 3, 4. You can always do better labeling, like use subscripts like C, S, E, and T if you want to. But let me also get the sizes of each of these. For n sub 1, we have how many? 1, 2, 3, 4, 5. That's the minimum number you can have, so that's good. N2 will be 7. N3 will be 6. And then N4 will also be 6. Capital N will equal 5 plus 7 plus 6 plus 6. That will equal 24. And then finally K, there's a total of 4 of them. So I've got all those numbers down. Now let me get my H sub 0 and my H sub A. Let's see what we're trying to do here. The table shows the amounts of caffeine in milligrams in 16-ounce servings for a random sample of beverages. At alpha equals 0.1, can you conclude that the distribution of the amounts of caffeine in at least one beverage is different from the others? So we could write the distribution of the amounts of caffeine in at least one beverage is different from the others. That's the claim. And then for H sub 0, the distribution of the amounts of caffeine is the same for all beverages, for all 4 beverages. And once again, you've got to organize all of the data. And remember, when you rank things, if you have an equal number, that you have to go to some sort of an averaging for those things. But if we don't, then you can just count them up. So I'm going to see here, I'm going to try to go by 6s. 1, 2, 3, 4, 5, 6, 7, 8. Maybe I'll go by 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Now let me go ahead and find our numbers. The absolute smallest that I see anywhere are T's. Just by looking at this, I can see that the energy in coffees dominate the higher numbers, and the teas and soft drinks dominate the lower numbers. In my mind, there is no way these 4 things have the same distribution of calories. So anyways, let's go through the rest of the process. Let me get my R's down. All right, for the first one, that was coffee. So R1, I'm going to add up all the coffee rankings. So I'll start here with 15. Plus, and then I'll move over to 206. Not 206. I want to put the ranking, not the not the amount of caffeine. 21 plus 22 plus 23 and 24. That's a total of 5. 1, 2, 3, 4, 5, and I think that was true for coffee. Let me write this down then. I get 36. 58, 81, 105. What was number 2 on my list? Those were soft drinks. So S represents R sub 2. And the soft drinks, they all go in a row. They go from 5 through 11. So that is a total of 7 of those. Let me slice these off. 2, 3, 4, 5, 6, 7. And that's 11, 18, 26, 35, 45, 56. Number 3 were energy drinks. Let's find all the energy drinks. They're in the higher sections. I've got a 14 plus, and then 16, and then 17, 18, and 19, 20. And what's that equal? 30, 47, 65, 84. A total of 104. And then the last, what was after energy drinks? Teas. Those are all the lowest ones. Let's see what my T's are. They're 1 through 4, 2, 3, 4. And then what else do I have? 12 and 13. So we're going to equal 6, 10, 22, 35. Now let's get our test stat. That's H equals 12 divided by capital N times N plus 1 times R1 squared over N1 plus R2 squared over N2 plus R3 squared over N3 plus R4 squared over N4 minus 3 times capital N plus 1. And I think we've said capital N is equal to 24. So I have 12 divided by 24 times 25 times 105 squared divided by, what was N1 again? N1, so I have 5, 7, 6, 6. 5, 7, 6, 6 minus 3 times 25. All right, let me get the next R. I have 56 squared. Next one after that is 104 squared, and then 35 squared. So let me go ahead and pull it up on the calculator. So the way I do it, I do 12 divided by, then I put in parentheses, 24 times 25. Finish that parenthesis and finish the outers. Now I'm going to start all that R business on the inside. So let me move this out of the way so you can see it. We're going to have 105 squared divided by 5 plus 56 squared divided by 7 plus 104 squared divided by 6 plus 35 squared divided by 6. I'm going to finish that parenthesis and I'm going to subtract 3 times 25. Enter. So I get roughly 18.197. All right, now let's go ahead and get our critical value. Remember, this is a right-tailed test, so there's only going to be one of these things. Alpha was equal to 0.01. Degrees of freedom, that's equal to k minus 1. That's 4 minus 1, so our degrees of freedom is equal to 3. And let's go ahead and pull up the chi-squared table. So I have degrees of freedom 3, and my alpha is 0.01. That is 11.345. So we draw a picture like so. Where is our test stat? As I suspected, it is way in the critical region, so we reject H sub 0.